We are going to start arithmetic sequences today. Go ahead and give yourself a Cobra heading. Today is the 9th November, and fill in the period. So, in order to look at arithmetic sequences, we need to know what they are. So, it's a sequence of values, so it's a list. For example, 1, 3, 5, 7, dot, dot, dot. And it has a common difference, meaning that you are adding the same term, or sorry, the same value every time. So, plus 2, plus 2, plus 2. The next term would be 9, 11, and on and on. The common difference means that this sequence is a linear function. So if you were to graph these values, they would be in a straight line. It would be discrete because you have a first term, second term, third, fourth, fifth. It's position in line. There's no such thing as the 2.5 term or the 3.75 term. So it would be discrete rather than continuous, which means we wouldn't connect it on a graph. The reason we're studying it now, though, is because it does make a line. So just like when we were looking at linear equations and writing their equations, the important pieces of y equals mx plus b were the slope and the y-intercept. When we're looking at the important pieces of an arithmetic sequence, we're looking for the first term and the common difference. So it's very similar to what you've already done, it's just a different notation. So a sub 1 means the first term of the sequence. So in this case, the first term will be 1. And d is the common difference. So what are you adding every time? In this case, you're adding 2. So you would simply put a 1 here and a 2 there, and you would have your sequence. You can also use function notation. So instead of a sub n, you'll see f of n. Instead of a sub 1, you'll see f of 1. It's the exact same thing. The exact same thing. It's just written in function notation. Those are called the explicit formulas. The explicit formulas are the most useful because if I ask you to find the 20th term, you can plug in 20 for the term number and find that term immediately. But there is also a recursive formula. The recursive formulas still has the same two pieces of information, your first term and your common difference, but this time it defines the term based on the one before it. The downside of these is to find the 23rd term, you have to find term 22, which means you need term 21, which means you need term 20, which means 19, 18, etc., etc. The reason, though, that we use them, even though they are such a pain, is because there are some sequences that are not arithmetic that are used only with a recursive formula. They can't be done any other way. One example is the Fibonacci sequence that you may have heard of. It's pretty famous, and we'll talk about it some more over the course of the next 3 class periods when we're looking at a few of the other kind of sequences. But let's look at what some of these notation parts mean. So a sub 1 means the first term, I'm sorry, that says a sub n. I apologize. A sub n represents the nth term. The nth term. So what that means is a sub n, a sub 8 is the 8th term. A sub 30 is the 30th term. A sub 29 is the 29th term. So it's whatever term number you're interested in. A sub n minus 1 is the term before. The term before. So if we're interested in the 4th term, then a sub n minus 1 is the 3rd term. If we're interested in the 25th term, a sub n minus 1 is the 24th term. Then a sub 1, that is the first term. So it's the first number in the sequence, the first term. A sub 1 is the first term. D represents the common difference. So D for difference, it's what you're adding every single time. And if the numbers are getting smaller, then you're just adding a negative, which is also known as subtracting. Well, that's how much the terms are changing by each time. Plus 2, plus 2, plus 2. And the first one I showed you. Or minus 8, minus 8, minus 8. Well, that's how things are changing. So the rate of change when we're talking about a line is known as slope. So the slope of the line is the same as the common difference of the sequence. And then n represents the term number. So if we want the 45th term, 45 is n. So you will also see these written as ordered pairs, x comma y, just like our normal graph, or you could see it written as the term number and then the term. So like term in the one above, 1, 3, 5, 7. Let me just rewrite that really quickly. So if I wanted to write that in ordered pairs, I would write 1, comma 1, because that's the first term, or 2, comma 3, because it's the second term, 3, comma 5, it's the third term. So it's simply its place in line. All right, so here's an arithmetic sequence. We are going to write the first 4 terms as ordered pairs and then find the common difference using the slope formula. So the x value is its place in line. So this is the first term, second term, third term, fourth term, fifth term. The ellipsis means and so on. So I would have 1, comma, negative 19. I'd have 2, comma, negative 9. 3, comma, 1. 4, comma, 11. And I could keep going, but it said find the first 4 terms. Then it says use the slope formula. Well, the slope formula can be used to find the rate of change or slope between any 2 points on a line. So I get to choose my favorite of those points, and I like positives. So I'm going to choose these 2 points. Remember, slope formula is y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Those subscripts mean just the first point, the second point. So I'm going to do fraction minus minus. Remember I talked about that helps me with my negatives. So then I'm going to do 11 minus 1 over 4 minus 3. So 11 minus 1 is 10. 4 minus 3 is 1. So the common difference is 10. So if you go back and look, each time to get from one term to the next, you're adding 10, adding 10, adding 10, adding 10, adding 10. So that common difference of 10 is the slope of the line if I were to graph them. So the common difference and the slope are the same. All right, so now we want to find an ordered pair that represents the nth term of the sequence. So if you look at the sequence from here to here, to here, to here, to here, each time you're doing the same thing. Each time you're adding 9, adding 9, adding 9. So that means it's an arithmetic sequence. Once I know it's an arithmetic sequence, then I know that a sub n is equal to a sub 1 plus n minus 1 times d. The 2 pieces of information that I need are the first term and the common difference. Well, the first term is literally the first on the list, so 14 is the first term. And then the common difference is what I'm adding every time. And of course, if I'm subtracting, it's just adding a negative. So here we said we were adding 9 every time. So this is a 9. So a sub n is 14 plus n minus 1 times 9. Now, if you look, all the choices have an x value of n, so that's just the term number. But none of these y values match this. So if you look, they have simplified. So let's go ahead and let's distribute. N times 9 is 9n. Negative 1 times 9 is negative 9. So if you combine like terms here, you've got 14 minus 9 makes 5, because they're different. Subtract, take the sign of the larger. And then plus 9n. So right here. So n is your term number. So like 1, 14, 2, 23. And then the y value, 5 plus 9n, comes from using the first term and the common difference. Those 2 pieces of paper of information are what you need every single time. All right, so we're going to write the explicit formula for this sequence. Notice it is a line. Notice again that it is discrete, as I mentioned, because its x value is the term number, so it's not half a term, it's first, second, third, fourth. So the formula is a sub n equals a sub 1 plus n minus 1 times d. And unfortunately, yes, you do have to memorize that. But the only two pieces of information that you need are the first term, the common difference. So the first term right here, if you go to term 1, is 1. So 1. Then we need to find the common difference. Well, the common difference is the slope of the line. So I'm going to count rise over run. So 1, 2, 3, 4 over 1. So the common difference is 4, or the slope is 4. You might see it written that way. You might see it written with the 4 in the front. Or you might see it with the 4 distributed. You can see a sub n is 4n, and then 1 minus 4 is negative 3. Either way, either this or this is your more common, but the other two are also equivalent. Then it says find a sub 8. So that means find the 8th term. So a sub 8.
Ms. McMullen, please call the front office. Ms. McMullen.
So a sub 8 is 4 times 8 minus 3. So 32 minus 3 is 29. So that means if I extended this graph out to x is 8, y would be 29. All right, that was an explicit equation. So let's use this here and do another explicit. So a sub n is equal to a sub 1 plus n minus 1 times d. So we need the first term, we need the common difference. So find the first term and the common difference. So the first term, right there, the first one's negative 7. The common difference is what you're adding. So from here to here, to here, to here, you're adding a 3. So you could leave it like that, or you might see it distributed. Then the 25th term, a sub 25. Go ahead and do the arithmetic and see what you get for the 25th term. So it's like 65 would be the 25th term. All right, so those were using the explicit formulas. The benefit of the explicit formulas is that you can find any term you want just by substituting the term number without having to find all the terms before it. So I can find term 50 without finding terms 1 through 49. Now we're going to look at...
Good morning. Ms. McMullen, please call the front office. Ms. McMullen, please call the front office.
Now we are going to look at the recursive formula. The recursive formula is less helpful for most people, but the reason we need it, again, is there are some formulas that can only be defined recursively, so we make sure that we know how to use the formula in both explicit and recursive formats. So we're going to look at the term to the left. So this one we did a few minutes ago. We still need the first term and the common difference. Well, the first term we said right here, term 1 was 1. The common difference we said was the slope of that line. So we counted rise over run and got 4. So we just express it differently. The first term is written by itself, and then every other term is the term before it. So a sub n minus 1 just means the term before. So the fifth term is the fourth term, and then plus the common difference, which in this case happens to be 4. So the 28th term is the 27th term plus 4. The 90th term is the 89th term plus 4. So to find each term, we would have to find the term before it. Definitely not very efficient. All right, now we're going to look at this one here where we find the recursive formula, and then make sure we also put it in function notation. So to write a sequence, we need two things. First term, common difference. Well, the first term it tells us right there is 5. So a sub 1 equals 5. So we're halfway there. The common difference is also known as slope. So what I'm going to do is I'm going to write these as ordered pairs. Term 1 is 5. Term 8 is 33. That allows me to find the slope. So I'm going to do 33 minus 5 over 8 minus 1. So 28 over 7. So the slope is 4. So the recursive form would be that the first term is 5, and that all the other terms are the term before plus a common difference of 4. It says included in function notation. All we do is change f of 1, I'm just kidding, sorry, change a sub 1 to f of 1, and change a sub n to f of n. A sub n minus 1 becomes f of n minus 1, and then plus 4. So the only difference between the subscript notation and the function notation is just that being fancy again. Remember we said f of x is fancy y? So f of 1 is fancy a sub 1. F of n is fancy a sub n. You're still looking at those two pieces of information. The first term, common difference. All right, let's take a look at this last one. It wants to know which statement about the sequence is false. And I will tell you there's actually two of them. One of them has a typo, so there are two false ones here. So the first statement says that it's arithmetic. Well, in order to determine that, we need to see, are we adding the same thing every time? So if we look from 23 to 18, we're subtracting 5. From 18 to 13, we're subtracting 5. From 13 to 8, we're subtracting 5. 8 to 3, subtracting 5. So that's true. It is arithmetic because we're adding negative 5, same thing as subtracting 5. The common difference is 5. Well, that one's false. We said the common difference is negative 5. It would be negative 5, so that one's false. And I told you that there's more than one false one, so we're going to keep going. This one wants the third term. So 1, 2, 3, right there is 13. So yep, that's true. This one wants to know what the 8th term is. Well, they only gave us 1, 2, 3, 4, 5, so we're going to have to calculate it. So let's use the formula. A sub n is a sub 1 plus n minus 1 times d. We know that the first term, right here, it's first, is 23. We know we want the 8th term, so n is 8. And we know the common difference is what we're adding every time, which in this case is negative 5 because we're actually subtracting. And now it's PEMDAS, so 23 plus, you would do parentheses first, 8 minus 1 is 7. So now I have multiply and add. Of those two, multiply comes first. So 7 times negative 5 is negative 35. So 23 minus 35 is negative 12. They say it's 212, so this is false. As also follows, it should be negative 12, which is where that typo comes in. That should have been a negative instead of a 2. So negative 12 is indeed the 8th term. So it's a lot of notation. It's easy to get overwhelmed. Just give yourself some time and be patient. All you need to know, this all boils down to the first term and the common difference expressed in different forms based on which kind of formula we are using. So yes, you will need to know explicit.
Good morning, faculty and staff. With the mothers